Hello students, I am Mansi Agarwal, Assistant Professor, ABES Engineering College, Ghaziabad. Today we will be discussing our next topic of data structure, that is Radix sort. In the previous lectures, we have discussed the counting sort algorithm, which will be used in this Radix sort algorithm. So the Radix sort algorithm is a linear sorting algorithm that sorts array by working on the place values. It starts processing them digit by digit by repeatedly sorting the elements by their significant digits from least significant to the most significant. Radix sort achieves the final sorted order. So to have a better understanding of how this algorithm works, let us take an example wherein we can take 10 different numbers which are stored in an array in unsorted manner. So suppose this is an array and let us take various numbers like 192. We can take any value. Suppose these are the values that we have taken and we want to sort them with the help of Radix sort. So in order to sort them using Radix sort, first of all, we have to check that what is the maximum number of digits, maximum number of digits which are possible inside this input. So the maximum number of digits that are there in the maximum number is equivalent to 3. So we will see that in this Radix sort algorithm, there will be 3 passes. So let us start by understanding how the pass 1 will work. So for pass 1, let us just first write these input values here. And in the first pass, what we are going to do is we are going to sort these values on the basis of the numbers, the digits that are stored at the ones place, in this array. So in order to do so, what we can do is we can here create a table in which I can write all the digits which are possible from 0 to 9. Let us write all the digits that are possible from 0 to 9. And now we will keep on sorting the numbers based upon the ones digit. So let me check if there is any number which is having 0 on the ones digit. No, there is no number. Then we will look at the numbers which are having 1 at the ones digit. Yes, we have a number. We have this 591. So we will write this 591 over here. Let me just create some rows so that it becomes easy for us to understand. Right, so this is 591. Now we will check whether do we have any number in which we have 2 at the ones place. So yes, we have 192 here, 192. So in the next column, we will write here 192. Then we will look for any number having 3. No, there is no number. Then we will look for any number having 4. Yes, we have this number. We have this number 344. It will come in the 4 column. and we can write it over here, 344. Then we will look for numbers having 5 at the ones place. Yes, we have 435 here. We can write 435 and there's no other number. Then we will look for the numbers having 6 at the ones place. Yes, we have 786. So we can write down 786 over here. Then we will look for the numbers having 7. That is 937. We have this 937. We'll write it here. And then we will have this 597. We will write 597 here. We'll write 597 here. Yes. Then we will look for the numbers having 8 at the ones place. So we have this 508. We can write it here, 508. And then we have this 638. We can write this 638 over here. 638 will be written over here. Then we will look for the numbers having 9 at the ones place. Yes, we have 639. We have 639. So here I have to create one more column. We will write 639 here. 639. Here. And then after this pass, we will start picking up the values column wise, right? We will start picking up the values column wise like this. So there is no value in the column 0, then there is one value in the column 1. So after this pass, the array will look like this. The array will look like this. It will have 591 on the first place. Then we will have 192. Then we are going to have 344. Then 435. Then we will have 786. Then we are going to have 937, 597, 508, 638, and 639. Right? And how we have got these values? How we have got these values with the help of counting sort? We have applied counting sort only on the ones digit. Only on the ones digit we have applied the counting sort, right? So in this way, we have found this. We have converted the input into this form, into this form after pass 1. Let us now see how the second pass will work for these values. So for second pass, we have again written the input array after the first pass that we have got after the first pass. And again, we are going to do the same steps. We are going to execute the same steps, but this time we are going to work on the tens digit. We are going to work on the digit which is placed at the tens place, right? So here, if we can see that in order to find out the number which is having 0 at the tens place, we are going to traverse it and we have got 508. So this 508 will come here. Then there is no number having digit 1 or 2 at the tens place. Then afterwards, we are going to look for 3. Yes, we have 435. So we will write this 435 here. And then we have 937. We are going to write this 937 here. Then we have these two. We have 638 and 639. All these numbers are having 3 at the tens place. Then we are going to look at the numbers having 4, which is 344. We have this 344 here. Then there's no number with the digit 5, either 6 or 7. Then we are going to look for 8. Yes, we have this 786. So this will come here, 786 in the 8th column, right? Then we are going to look at the numbers having 9. We have 591, and then we have 192, and then we have this 597. And in this way, we have written all the numbers in the table. Now, again, we are going to traverse them column-wise, right? Again, we are going to traverse them column-wise. And by traversing them column-wise, whatever numbers we are getting here, they will serve as the input. these numbers, when traversed column wise, they will serve as the input for the next pass. So this was pass 2, this was pass 2, and now we are going to have pass 3. And as it was discussed that as the maximum number in this input was having 3 digits, so this third pass is going to be the last pass. So let me just quickly write down the numbers that we have got: 508, 435, 937, 638, 639, 344, 786, 591, 192, and 597. So these are the numbers that we have got after the second pass. Now we are going to again sort these numbers based upon the digit which is placed at the hundreds position, right? So again, we will make columns 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. In this way, we are going to make the columns. And then we are going to find out the number which is having 0 at the hundreds place. There is no number. Then we are going to look for 1. Yes, we have 192. We have 192. Then we are going to look for number 2. We don't have any number. Then we are going to look for 3. Yes, we have 344. 344 will be placed here. Then for 4, we have 435. Yes, we have 435 here. Then for 5, we have 508 will be placed here. 508. Then we also have this number 591. 591 will be placed here. 591. Then we are going to look for 6. We have 638 and 639. Okay, one number is missed. This number, we will place it here. 597. All right. So we have 638 and 639. Then we are going to look for 7. Yes, we have a number. And this will be placed in 7th column. So this will be 786. Then we are going to look for a number having 8. No, there is no number. Then we are going to look for 9. Yes, we do have a number. That is 937. Right? So this is past third. And again, what we are going to do is we are going to arrange them according to these columns. Right? So if you can see that if we arrange them according to the values that we are getting in the columns, if you see, we will get the sorted values. The first number is 192. Then we have 344. As we are going to go column wise, there is no number in this column. Then we will go in 3. So we have 344. Then we will go in 4th column. We have 435. Right? Then we have 508. Then we have 591, 597, 638, 639, 786, and 937. Right? So these are the numbers, and we have got these numbers. We have sorted these numbers successfully with the help of Radix sort. Now, let us just see how the Radix sort algorithm will work. Now, suppose the name of the algorithm is given by Radix sort. So this Radix sort algorithm is going to have 2 parameters, that is array and the number of elements. Now, suppose max is a variable which is storing the maximum number, stored among the array. So we can simply call this get max function. Now, what we have to basically do, we have to call the count sort algorithm, right? We have to call the count sort algorithm with this a and n for how many times? For the number of times that is being given by the number of digits this maximum number will have, right? Suppose there is an input in which the maximum digit is 1563. So in that case, we need to have 4 passes, right? And in every pass, what we are doing? We are just sorting the arrays with the help of count sort. So that is why we have taken this max. We have just taken the maximum number which is stored inside the input. Now for this, what we have to do, we have to call the count sort. So for this, let me just take a variable exponent which is equals to 1, and we have to keep on calling the count sort such that maximum divided by exponent is greater than 0, right? Till that time, we have to call the counting sort, and in this counting sort algorithm, we will also be needing this exponent value, right? Because there also we have to sort the values based upon the place value, right? So there in the counting sort, we will be needing the array n and exponent, and for every inside this iteration, we have to multiply this exponent by 10, so that for the first time this value is 1. The next time this value must become 10, because now we have to fetch the digits that are placed at the tens place, and then it should become 100 in order to fetch the digits which are placed at the hundreds place. Now coming upon the algorithm, that is the counting sort algorithm. This algorithm here, it will be a little bit modified. Right? So suppose the name of the algorithm is counting sort or count sort. The parameters that we are going to have is a, n, and the exp value that we are getting. The first and the foremost thing, as it was done earlier in the previous video, we have to initialize this C to 0 such that we can increment this counting array whenever we are going to get a number with the having the digit equivalent to the index, if you remember it, right? So let us just do this. But here we have to increment the value. We have to increment equals to n. Right? So we have to start this loop from I is equals to 0 to I is equals to n. And what do we have to do? We have to increment the counting array. We have to increment the counting array, right? So earlier what we did, we incremented the counting array by making the index of the counting array as AI. You remember it? We had incremented CAI. We have incremented CAI, right? But here we have to increment, we have to take AI, but we have to take the digits. Like first, in the first path, it should take the ones digit, then it should take the tens digit, and then it should take the hundreds digit, and so on. So for this, we have to divide this AI with the exponent, right? We have to divide this with the exponent, the value which we are getting as a parameter, and then we have to remainder it by 10, right? So let us just try to understand how this will work. The values that we had, suppose in the first pass we were having 192, right? So for 192, this value is AI. Now we are multiplying it with exp, which is 1. So the number will remain same, 192. And then we are taking its remainder by 10. So this value will become 2. What we have to do? We have to increment the counting array whose index is 2. So that now we have come to know that value 2. There is one number with the value 2 at the ones place, right? In this way, for each number of the input array, we are going to increment the counting array. Now let us try to understand this statement a little more for the tens place also. So for the tens place, when we will be in the next pass, the value of exp will become 10. Now when we will come here, this will become AI divided by EXP. So suppose the value of AI is 192. Suppose the value of AI is 192. This will be divided by 10 so that we will get 19. And then we will take the modulus of this number. So we will get 9. And then C of 9 will be incremented. Right? C of 9 will be incremented. So in this way, the counting sort will, in the first pass, it will work on ones place. In the second pass, it will work on the tens place and so on. Right? Now, after this, we have made the counting array, and now we have to make the cumulative frequency array. If you remember it, we have to make the cumulative frequency array. For this, the for loop will start from 0 and it will go till 9. Right? It will go till 9. And it will go till 9. And what do we have to do? We have to write Ci is equals to Ci plus Ci minus 1. Right? Ci minus 1. So in this way, we will get the counting array, and now it will store the frequency, cumulative frequency, such that we will come to know that how many numbers are less than or equal to any index. Right? Now what do we have to do? We have to traverse the input array. We have to traverse the input array. This time we have to traverse it from last. So I is equals to n minus 1, and here we have to go down to 1. That means we will leave one element that will be sorted by its own. Now here, what do we have to do? Earlier, what we used to do is, we will take AI, then we will see its value in Ci, and then value Ci will be stored as the index of Bi, right? Now, here what we are going to do is, we are going to take AI, that is the value from the input array, and then we are going to divide it by the EXP that we are getting, and then we are going to modulus it. We are going to modulus it by 10, and then this value we are going to see in the counting array, and then we used to reduce it by 1 because the indexing starts from 0. So we are reducing it by 1, and then we are finding it out in B, right? And the value which will be stored in the B array, that is the output array, is going to be A of I. Now, as we have to perform various passes in the Radix sort, we need to modify the input array so that the input array, we can get the changed input array in the next pass, right? So for this, we will do I is equals to 0 to n, and we will simply copy the content of Bi into AI. The content of Bi into A. So this is how the Radix sort algorithm will work. Now, as we have seen that the time complexity of counting sort algorithm was nothing but theta n. Time complexity, if we see for the counting sort algorithm, it was theta n. But here, what we are doing, we are actually repeating the counting sort algorithm for the number of digits that are there in the input, the maximum number of digits which are there in the input. So suppose if the number of digits that are there in the input is k, so this counting sort algorithm will be called for k times, right? So if we see the time complexity, of Radix sort, it is represented by O of nk, where k is the number of digits in the highest value, right? So if we talk about the best case, worst case, and the average case complexities of Radix sort algorithm, we can say that it is On if the number of digits in the input are very few with respect to n, right? If the value of k is very less than n, then in that case, we can say that complexity can be represented as On, right? But in case of worst case, In case of worst case, if we say that the number of digits are also very high, then we can say, and if we say that the number of digits are almost equivalent to the values that are there in the array, in the input array. So in that case, the worst case complexity will reach to n square, right? If we talk about the average case, then we can say that the number of digits is tending to log n. Then we can say that the average case complexity of radix sort will become n log n, right? So these are the references that have been taken, which includes Tenenbaum and Langsam, data structures using C and C++, Horowitz and Sahani, fundamentals of data structures, data structures, Shom series, and Tereja's data structure using C.